Welcome to the Math Burger. Today we'll be covering the CCML Algebra 1 Contest for 2015-2016 Division A. Okay, number 1. Simplify 2 minus 3x minus 2. Okay, basically all you have to do is just 2 minus 3x, and then minus the negative 2 is just plus 2. So that just simplifies to negative 3x plus 4. So that's just a simplified version, basically just that simple. Okay, number 2, solve for y. Negative 3y minus 5 is greater than 9. Okay, so we have negative 3y. Get the negative 5 to the other side, so you add 5 to both sides, so you get 14. And then divide by negative 3. When you divide by a negative, you change the sign, so this becomes less than 14 over 3. Negative 14 over 3, sorry. Negative 14 over 3. So this would be your answer. Y is less than negative 14 over 3. 3. Solve for b. 1 is equal to b plus 5. So you just have 1 is equal to the positive, which is, if b plus 5 is positive, just leave it as b plus 5. But b plus 5 is negative, like results in negative, just multiply by negative to make it positive. So it'll be negative b minus 5, because that's what absolute value is. Just the positive version if it's positive, and then, so it's just the same number, and the positive version of the negative number, which is just the positive. So subtract 5, so you get b is equal to negative 4. Have b to the other side, so that b is here. And then negative 5 minus 1 is negative 6. So the answer is negative 4 and negative 6. I usually just use a comma. So this is your answer. Sorry. Negative 4, negative 6. Okay. Number 4, if f of a is equal to 25, given f of x is 2x plus 7, determine the value of a. So we have a, so we plug that in, so we get f of a is equal to 2a plus 7. Oh, sorry. And then we can have f of a, which you just put 2a plus 7 into x. You get 2 times 2a plus 7, which is just 4a plus 14. The 14 has a 7 in the end, so plus a 7 makes 21. Is equal to 25. And then 25 minus 21 is equal to 4, so a is just equal to 1. Another way would be you could reverse from the back. So you could basically just say you have 25 is equal to 2x plus 7. So you subtract it, so you get 18 is equal to 2x, so x is equal to 9. And then from 9, you just have to reverse it again because you're putting it in again. So 2x plus 7 is equal to 9. And then subtract 7 is equal to 2, so x is equal to 1. That's another way to do it, which is probably the faster way. Question 5. If the system 3x plus 5y is equal to 13 and 8x plus by is equal to 39 has more than one solution, determine the value of a and b. Since they have more than one solution and it's linear, that means it's basically the same line. So we need to get the 13 into 39. So multiply by 3, that gets 9x plus 15y is equal to 39. Then you have ax plus by is equal to 39. So since they're the same, a is equal to 9 and b is equal to 15. So determine the sum, which is just 24. 9 plus 15 is 24. Basically just that simple. Okay. Number 6. Solve for h. 18 minus 2 times 5 h plus 4 parentheses equal to 7 times 5 h plus 4 parentheses. So we have 18 minus 10 h. Sorry about that. Minus 16 minus 10 h, and then minus 8 is equal to 35h plus 28. Add h to both 10h to both sides, so you get 45h. And then 18 minus 8 is 10, minus the 28 is negative 18. So h is equal to negative 18 divided by 45. They're both divisible by 9, so that's negative 2. That's 9 of here is 5, so the answer is negative 2 over 5. Okay. Number 7, determine the value of c. 110a, whatever a is variable for the units digit, base 11 is equal to c base 12. Note that in bases higher than 10, it's customary to start using letters of alphabets to represent d higher than 9. Here, a represents the units digit of base 11, represents the units digit of the base 11 number. So we have to find c. Basically, what it is that since we're using the normal number system, it's just like 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what they're basically saying from the note is basically A will be equal to our 10, and then B will equal to our B will equal to our 11, C will equal to our 12, D will equal to our 13. But this C right here is a variable, so it's not C is equal to 12. So we just had to like find out what C is. So how to convert from base to actual like from base like any base to base 10. Basically what you do is that you multiply whatever the base is to the power of the placeholder, and then you basically just add the results. So what you do is that you have 100 a, so you have 1 a 11. So it will be 11 squared times 1, so 1 times 11 squared, and then you add 1 from the tens digit times 11, and then you have plus a times 11 to the 0. It'll make more sense. 11 to the power 1 plus a times 11 to the power 0. So that's basically how this works. And then you have more, you just have 11 to the power 3, 11 to the power 4, etc. And if you have decimals, you have like 11 to the power -1, 11 to the power -2. So that's basically how it works. So based on this, we have 121 plus 11. Remember, a was 10, and 11 to the power 0 is 1, so this is just plus 10. So that's 21, so that's 142. So 111a is base 11 is 142 base 10, which is the normal scale that we use by. And then we have to put this in base 12. So what we do basically is that the way that we do to convert to base 10, now we're going to do the reverse. So we got to think of the highest number that 12 could go up to a power of that is lower than 142. 12 to the power of 2 is equal to 144. So this is higher than this, so you can't do that. So the highest you could go to is 12 to the power of 1. So 12 to the power of 1, right? What number can multiply to 12 to a power of 1 that could get us to 100 that's less than 142? Because 12 times 2 is just 12 squared, right? Which was just a little bit higher, so I expect it to be 12 times 11. So the coefficient for the first one is 11, which is b. Because remember, a is equal to 10, and b is equal to 11, and c is equal to 12. Well, you're gonna use b. You're not gonna write like 11 like 2, 5, like as the number. Because it doesn't make sense to use like 2 digits to count as one single digit. So you have b, and that's what we're gonna write. So 12 times 11 is so we have 11 here. 12 times 11 is equal to 132. So 142 minus 132, you have 10 left over. So since it's 12 to a 1, that means the next one is 12. The one below is 12 to 0, and 12 to 0 is just 1. So 1 times any single number is just 10. So times any number which is equal to 10. So that number has to be equal to 10, right? So 1 times 10 is equal to 10. So 10 is equal to a. So our answer for question 7 is just BA base 12. That's what our answer is. Because we just do the math on it. B, which is 11, so it will be 11 times 12 plus 12 to the power 1, and then A, which is just 10 times 12 to the power 0. And that should get to equal to 142. So the answer is just BA base 12. Number 8. Determine the slope of the line passing through 3, -2, and 2, -2. So you have 3, -2, so right down here. And then you have 2, -2. We have a slope like right here. Since it has basically the same y-coordinate, that means the slope is 0. Because it's going to be a horizontal line. Solve for y. -2 y minus 4y plus 5 is equal to 1. So let's just get all the constants into one side. So you have 7 minus 4y, okay, which is equal to 1 minus 5 is -4, and -4 divided by -2 is just 2. So we just need 7 minus 4y is equal to 2, which makes sense because -2 times 2 is -4, plus the 5 is 1. So we need this to be equal to 2. So we have 7 minus 4y. If it's positive, then just leave it as positive, equal to 2. And then if this 7 minus 4y is negative, just multiply by -1. So -1, -7 plus 4y is equal to 2. So we have 5 is equal to 4y. So y is equal to 5 over 4. Or we have 4y is equal to 9. So we have y is equal to 9 over 4. So our answer is just 5 over 4 and 9 over 4. Basically just that simple. It's just a little bit more difficult than number 3, or question 3. Question 10. Determine the solution to y is equal to x minus 3 plus 4, and y is equal to negative x over 2 minus 2. So what I technically do first is that I want to get a pretty good picture. Absolute values are basically a v. So it's going to be at centered at 3, 4. So it's going to be 3, 4, so somewhere here. That's its vertex. And since I see that it usually absolute value goes like this, since it's positive, right? It kind of looks like an upper V. But since it's a negative absolute value, we're gonna go down. So it kind of looks like this. Oh, so, yeah. And then we have negative x divided by 2 minus 2. So we have something here, and then we have to minus even more, right? So technically, there's gonna be an answer like right here, and like one that's probably gonna like hit right here. So that's gonna be a general idea. So there are like a possible 2 solutions. So let's just make the absolute value equation into like 2 equations. So we have so if this was positive, right? We'll just leave it as positive. So it'll be x minus minus 3 as positive plus 4. So that kind of simplifies out to negative x, and then negative of -3 is plus 3, and then plus is plus 7, right? Or if x minus 3 is negative, we just multiply by negative to get negative x plus 3, and then we multiply, since it was a negative in front again, we're just gonna multiply by negative again. So then multiply by this negative x plus 3 by negative, so we get x minus 3. So it just leaves x minus 3. Because think about it, if x minus 3 is negative, then the absolute value just makes it positive, but the negative outside makes it negative back again. So it's just x minus 3 plus the 4, which is x plus 1. And then it has to equal to the other equation, which is negative x over 2 minus 2, and negative x over 2 minus 2. So using that, let's just solve this. Add x to the other side. We have add 2 to the other side, so you have 9 here. And then this gets x over 2, so x is equal to 18. Let's actually write this a little bit smaller. X is equal to 18. So if x is equal to 18, then y is equal to, plug it back to one of the original equations. So 18 divided by 2 is 9, times -1 is -9, minus 2 is -11. Let's check if that's right. So 18 minus 3 is 15, negative 15, plus 4 is -11. So yes, that's true. And now for the next equation, which is x plus 1 is equal to negative x over 2 minus 2. Add negative x over 2 to the other side, so you get 3x over 2 minus 1 to get negative 3 equals to negative 3. Okay, so you multiply by 2/3, so x is equal to negative 2. So y is equal to negative 2 divided by 2 is negative 1 times negative 1 is 1 minus 2 is negative 1. So we have and then we have, yeah, so this is true. So these are our two coordinates. So these are our two solutions. So you gotta write that in the form, which is 18, negative 11, negative 2, and negative 1. So these are our two solutions. Negative 18, negative 11, and negative 2, negative 1. Okay, question 11. Determine f of negative 3 for f of x is equal to f square root of x squared minus 2x. So 5, negative 3 squared is 9, minus 2 times negative 3 is plus 6. So square root of 9 is 3, so 5 times 3 plus 6. That's 15. 15 plus 6 is 21. So the answer for number 11 is just 21. Number 12. Two hoses are filling a swimming pool with Kool-Aid. The first hose by itself takes 7 hours to fill the pool, and the second hose by itself, um, takes 1.5 hours to fill half the pool. So how long would it take to fill 2/3 of the pool if both hoses are used? So the first hose takes 7 hours. So you think about it, well, the rate, let's just say the rate of the first hose by itself is, if it's just a hose by itself filling its pool, it would just be the number of hours divided by 7, because that will be the rate of the first one. We'll call that R1. Okay. Because think about it, because if you have x is 7 and you want to fill out the entire pool, which is equal to 1, because it's 1 of itself, then you need 7 hours. 7 divided by 7 is 1. So that's how you usually think about it. It's x divided by how long it takes. And then we have rate 2, which is the second hose. By itself takes 1.5 hours to fill half the pool. So if it takes 1.5 hours to fill half, that means to fill the entire pool it takes 3 hours. So this one's just x over 3. So how long would it take to fill 2/3 of pool if both hoses are used? So the rate would just be x over 7 plus x over 3, because it's both of them, so you have to add both the rates together, which equals to 2/3 of the pool, right? And then doing this, we could just have 1/7 plus 1/3, which is just if you multiply 1/7 by 3, that's just 3 over 21, and 1/3 times 7 on top and bottom is just 7 over 21. So that gets 10 over 21. Okay. So 10 over 21x is equal to 2/3. So multiplying by 21 over 10, cancel this part out. And this multiplied by 21 over 10 here makes 1. So 3, that makes 7. Divided by 2 is 5 here. So x is equal to 7 over 5 hours. So 7/5 hours. That's how long it takes. Okay. Question 13. Give the value of the order pair xy that solves the equation 5x plus 3y is equal to 4 and 2x is equal to 1 plus y. So you have 5x plus 3y is equal to 4. And I'm going to put this in the same form, so it's 2x. Then you might have minus y is equal to 1. So multiply the second equation by 3, so you get 6x minus 3y is equal to 3. Add them together, so the y's cancel out, so you get 11x is equal to 7. So x is equal to 7 over 11. And y, just plug it into one of the original equations, like the original second equation, so that's 14 over 11 minus that 1, minus 11 over 11, because that's equal to 1. That gets 3 over 11. Okay. So the answer for number 17 is just 7 over 11 and 3 over 7 7 over 11 and 3 comma 3 over 11. Question 14. Solve for W. Absolute value of 9 minus 5W is greater than 2. Give your answer as an inequality on W. So if 9 minus 5W is positive, as I keep saying before, we just have 9 minus 5W is greater than 2. And we have if 9 minus 5W is negative, just have negative 9 plus 5W is greater than 2. So U minus 2, that's 7, is greater than 5W. And add 9, so you have 5W is greater than 11. So 7 divided by 5, W is less than 7 over 5, and W has to be greater than 11 over 5. So these are your answers, which is just W is less than 7 over 5, or W is greater than 11 over 5. Number 15. Given two fractions a divided by b and c divided by d, where a, b, c, and d are positive integers, if their difference ad minus bc has a numerator of plus or minus 1, then they are called neighbor fractions. What pair of unit fractions are neighbors of 211 and neighbors of each other? So instead of using so it says a, b, c, d are positive integers and they have to be unit fractions. So so a, b, c, d can only go from 1 to 9. And they has be and they're neighbors of each other and they're neighbors of 211. So let's just use a, b, and 211. So that tells us using the difference between them would be 2 a times b, which is just 2 ad, which is just 2, because if d is equal to 2, I mean if c is equal to 2 and d is equal to 11, right? So you have a, b, and c, d would now be 2 to 11 in this case where we could plug into here. So it'll be ad, so it'll be 11a, and then minus bc, which is just minus b, and our c, which is 2, all over bd, which is going to be a 11b. I mean 11, sorry, it's bd, so it's b and d, yeah, 11b. So using this, they say the numerator part has to be a plus or minus 1. So if this is plus or minus 1, 11a minus 2c is plus or minus 1. This tells me the only way for this to be possible, which AC has to be like units, a fraction, has to be units digit, would be like if this was 11 and this was like 10. So we have like 1 and 5. Or like vice versa, which would be like if this was 11, if this was like if this was, because the difference would be like if this was 11 and now this is 12 instead of 10. So then we could have like C would be negative 6, right? And this would be at 1. I mean, sorry, negative 1. So that would be negative 11 uh, plus 12, which is minus 1. I mean, plus 1. Or you could do the same case if it's minus 1, so you have to put just 1, 6. And the same case for 1 and 5, which is just negative 1 and negative 5. So that would be negative 11 plus 10 is negative 1. So these are the only 4 cases that work. So since they're positive, we have A and C. I mean, why did I put C? This is B. Sorry about that. B. Right? So the two numbers is just A divided by B, which is just 1 over 5. 1 over 6. This is also 1 over 6, and this is also 1 over 5. So these are the only two like possibilities for A and B. Since you could just change AB into CD, like the actual CD right here, technically these are the only two pairs. So these are just, so this is just the answer. 1 over 5 and 1 over 6. Is there gonna be neighbors to 211 and neighbors to each other. So those are the only two pairs. You could check if you want, but you really don't have to. Number 16, determine the equation of the line perpendicular to 3x plus 4y is equal to 25 that passes through the point 1, comma, 4/3. Write your answer in slope-intercept form. So we have an easy way to do this based on this equation is that you switch the coefficients for x and y, and then you make the coefficient in front of the y negative. So you just have 4x minus 3y. And it has to go through the point 1 4/3. So it has to go through. So at 4 times 1 is 4, and 3 times 4 over 3 is 4. That's 0. So we have this is equal to 0. So move 3y to the other side. So this is equal to 3y. So 4/3 x is equal to y, which is gonna be our equation in the slope-intercept form. There's just no intercept, so this is the slope. So number 17, solve for a. AB minus CD is equal to AC plus BD. So let's just get A to one side, so it's AB minus AC. And then you have CD plus BD, right? So you have A, B minus C, and then you divide D, get D out, which is C plus B. So since none of these kind of like cancel each other out, we just have A is equal to D times B plus C all over B minus C. So that's how you solve for A. Just get all the variables on one side and get everything else on the other, and you basically solve it. Tim is selling cookies to raise funds for his school's math team. If he's selling customized 4 packs of cookies, which is made possible by robots, students can choose from 3 cookie varieties: oatmeal raisin, a chocolate chip, or sugar. How many different 4 packs are possible? So there's 3 of them. Let's just call them A, B, C, D. I mean A, B, C, D, right? So there's only technically uh 3 types. So if you only have one of a kind, so maybe if it's like all like um raisin, all chocolate chip, or all sugar, or there's 2 of a type, which is just like raisin, chocolate chip, raisin, sugar, etc. and stuff like that, or you have 3 of a kind where you have all of them. So those are only 3. So let's say you only have one of a kind. That's all. So all 4 is raisins, all 4 are chocolate chip, or all 4 are sugar. So there's only 3 possibilities from there if it's one. So if we have 2 of a kind, right? If we have 2 of a kind, let's just say there's only 3 possibilities, which is oatmeal raisin. So let's say AB, or like oatmeal raisin, which is in sugar, which is AC, and then you can see the last one, which is BC. So these are the only 3 combinations where you um where you use only 2 of them. So this is what happens when you have like since there's 4 of them, you can have like 1 and 3 of, or like 2 and 2 where they're equal. So, or you can have 3 and 1, right? So these are only possibilities. So there's 1, 2, 3 for each of them. So that's 3, 6, 9. So there's 9 possibilities. Because these are each possibility. You have 1 of A, 3 of B, 2 of A, 2 of B, or 3 of A and 1 of B. So or you could do the same case for AC and BC. So there's 3 for 1, 3 for the second, and 3 for the third. So that's a total of 9. So there's 9 possibilities for this one. For 2. Now if we have 3, we have to combine A, B, and C. So if it's A, B, and C, there's only one spot left. The only thing you have to put is a B, or a C. So based on this, the only thing that you could have is you had to have these 3. So the 4th one has to be like these 3 possibilities. So that's 3. So altogether, it would just be 3 plus 9 plus 3, which is 15. So the answer for number 18 is 15. Okay. Number 9. Give the value of the order triple xyz that solves 2x minus y is equal to 5, y plus 3 z is equal to 16, and x plus z is equal to 8. So let's just add the first equation and the second equation, so you get 2x plus 3z is equal to 21. So, and we also have x plus z for the third equation is equal to 8. So multiply this equate x plus z is equal to 8 by negative 2. So you get negative 2 x minus 2z is equal to negative 16. So then adding this equation with this equation, you kind of get z is equal to 5. So if z is equal to 5, x is equal to 3. So we have 3 and we are missing y, and we have 5. So if 3 is 5, plugging it back to the first equation, we get 6 minus y is equal to 5. So y is equal to 1. So it's basically just that simple. So the answer for 19xyz is just 315. Question 20. How many rectangles can be made whose vertices are points on the square lattice? Okay, so since they gave me and they said using the points, that means it could tell. That basically tells me that that they're just trying to be tricky and that they want to make rectangles using uh lines, but the lines could also can ask be made by a point regularly or using diagonals. So let's draw this out. So we have 1, 2, 3, 4, and then you have each of them more. Okay. So based on this, to count the amount of ones just actually like using sides, it's really simple. You just basically count the amount of dots, and then you just have that amount of dots choose 2. Multiply the this is the vertical, and then you do the horizontal, which is also 4 dots. So 4 choose 2, and then you multiply those two numbers. So 4 choose 2 is 4 factorial over 2 factorial over 2 factorial, which is equal to 6. So 6 times 6 is 36. So the amount could be made out of with just like regular lines like this is 36 rectangles. That formula works because like it's basically the amount of lines choose 2. So you only choose 2 of them, and you don't care like what order it goes to, because you don't care if you choose this first and this second, or like you choose this first and then this is second, because it doesn't matter because it's the same line. And then you could basically choose like 2 lines from basically the verticals, and then you just make a rectangle. Or you choose this one and this one, which makes this rectangle. So that's basically the idea how to do it. So with 36. And now we're going to have to do ones with diagonals. So let's just worry about like inner like rectangles. We have one right here. That's 1. You have another one right here. That's 2. You have one right here. That's 3. You have one right here, which is 4. And then you actually have another one that kind of is like this rectangle, right? Because if you put those 2 squares together, that makes another one. So that's the 6th, and you put another one right here. That's the I mean that is the 5th, and this is the 6th. So there's 2 of those, and 4 of the red ones. So that is 6 for that. Now you gotta make like the outer squares because this could work. So let's say we use this point to this point, right? So that's a 2 to 1. So now we have to do the same thing. So this is a 2 to 1. So the next point you have is right here, 2 to 1. Next point right here, and then 2 to 1 right here. Since they basically have the same side length, basically that tells me that this all has to be like right angles, because this has the same angle measurement as this one, and this angle makes a 90-degree angle. So if this is x and this is y, right? And this thing is going by 2 to 1, this is 2 to 1, then this is also x and this is also y. And x plus y is 90. So this has to be also equal to 90. So this tells me every single else of the angles has to be 90, and that has to be a square. So it has to be a rectangle, because our squares are also rectangles. So there's one here. And also, you from there, you could also, let's say we don't start with this point, and now we start with this point. So we sorry, you put like a line right here, so it's 1 to 2 now instead of 2 to 1. Now it's 1 to 2, 1 to 2, and 1 to 2, which has the same concept, which now we have another one right here. So instead of doing this, we have this one now. So there's two more based on like the outer rectangles. So those are the only possible combinations that actually make sense. So now we have the edges, the ones that actually using the lines, 6 from the diagonals and 2 from the outer um, squares. Which so that's 36 plus 6 plus 2, that's 42, and that's 44. So the answer for number 20 is 44. This question is just kind of tricky because they say verticals. The answer would be different if they say they were using like if these weren't points and these were edges, right? And they say like how many rectangles you could make using these edges, then it's a different question. But that basically covers everything for the CCML Algebra 1 contest for 2015-2016 Division A. Thanks for watching, and I'll see you at the next math record.